I hope you remember that in our last class we have discussed about the games without saddle point. Now, before proceed to further new things, you have to understand one thing very carefully, that almost the game what exists in our real life, almost most of the games have game without the saddle point. That means the game which do not have the equilibrium point, as we have seen it already. Now, when we do not have that equilibrium point or the saddle point, we have to find out the optimal strategies and the value of the game by using the mixed strategies. And the formulas for the mixed strategies I have already given to you in our last class. I don't know how many of you have tried to find out the solution of these 6 equations, system of linear equations. If you solve those, you will get these values x1, x2, y1, y2, as I mentioned to you. Now, the problem with this kind of problem where the game does not have any saddle point is that we can find out the mixed strategies only for 2x2 game, because it is easy to find out. If you want to find out for mixed strategies for some game which is more than 2x2, the payoff matrix order is more than 2x2, it is very difficult to do. So that's why the methods what we are going to study now, we are going to study the method to convert a game which does not have any saddle point into a 2x2 game. And then we are going to apply this method to find out the mixed strategies. You have 2 methods in your syllabus to find out or to convert your payoff matrix into a 2x2 matrix where the equilibrium point or the saddle point does not exist. One is the graphical method, and next one is the dominance principle. So first of all, we are going to start with the graphical method. Is it okay to you what I've said to you already, that when we are going to solve any problem, any game problem which does not have any saddle point, then in that case you have to convert that problem into a 2x2 problem. And the method what we are going to study is basically a method to convert that game into a 2x2 game. So as I mentioned to you, that first method what we are going to discuss is known as graphical method of solution. Now, for the graphical method of solution, the game what we are going to consider, either it will be of this type. As you can see, this is a 2 cross n payoff matrix, or the game may be m cross 2. For only these 2 types, we can use the graphical method of solution. Clear to you? When we can apply the graphical method of solution? If any one of the player, either A or B, must have only 2 strategies. If this kind of game you have, then only you can apply the graphical method. Clear to you? Okay. Now, before proceed to say anything about the method or solution, I would like to give you one example so that it will be easy for us to understand that how we can apply graphical method of solution. And then I'll come back here also and to give you the idea. So the first problem what I'm going to consider, okay, as I mentioned to you, that actually the purpose of using the graphical method is to convert this 2 cross n payoff matrix to a 2 cross 2 payoff matrix. So after converting, after using that method, basically this matrix will convert to a matrix like that. Okay, which is basically, you can see it is ultimately a 2 cross 2. So this is our purpose of using that graphical method of solution. Now I'll proceed to solve a problem so that it will be easy for us to understand the graphical method. It's a very, very simple method. Just you need to understand the thing, what I'm saying. Okay, to all of you, till now, what I've said, the purpose of graphical method is to convert the game into a 2x2 game. We can apply the graphical method if any one of the player, either A or B, must have two number of strategies. Two strategies must have. Okay. Now, when you can see that this game is basically a 2x4 game. So that means we can apply the graphical method. And you can see that in the question it is given, they reduce the following game to a 2x2 game graphically. That means the question is asking to reduce that game from 2x4 into a 2x2 game by using the graphical method. Clear? And if it is not given to you also to reduce, you have to reduce, because graphical method does not give you the solution. Graphical method only can reduce the payoff matrix into a 2x2 matrix. Okay to all of you? Yes. Okay. Now you can see that here I have drawn two vertical lines. These two vertical lines will represent the strategy for the player A or for the player B. So obviously here, as the number of strategies for the player A is 2, so these two vertical line will represent the strategies for the player A. So I've written A1 and A2. Clear? Now, what I'm going to do, in this two vertical line, I'm going to write down some number. How do you write number? Number will come from this payoff matrix. I'm going to write down number from the minimum of the payoff matrix to the maximum of the payoff matrix. You can see that in this matrix, minimum element is -1 and maximum element is 3. So here what I'm going to do, I'm going to write down it is a -1, 0, right? 1, 2. Okay, if I take some more space also, that is also okay. -1, 0, 1, 2, 3. I'm going to write down each of the number, each of the integer value between -1 to 3. Whether it belongs to the payoff matrix or does not belong to the payoff matrix does not matter. I can extend it up to 4 as well. And here I can start with -2 also. That does not matter. But the number should be reflected between the lowest element in the payoff matrix to the highest element of the payoff matrix. Same way I'm going to write down here as well. Here I'm going to write down -2, -1, 0, 1, 2, 3, and 4. Is it okay to you up to this, please? Is it okay to you? Is it okay to you up to this?
Sir, can
Is
you
it
repeat once? My internet connection had a problem.
what? Yes. What I'm saying, that first of all, you have to draw two vertical line. Okay. And these two vertical line will represent the strategy for the player A or for the player B. If the player A have two strategies, then these two vertical line will represent the player A strategies. And if the player B have two strategies, then these two vertical line will represent the strategies for B. Here you can see that as it is a 2x4, so the number of strategies for the player A is 2. So that's why these two vertical line will represent the line, the strategy for the player A. So I've written A1, A2. And now what I'm going to do, I'm going to find out the lowest element in that payoff matrix and the highest element in this payoff matrix. And I'm going to write down the numbers into these two vertical lines. Is it okay, Manjari, now?
Yes, sir. Thank you.
Okay. Now what I'm going to do, I'm going to draw a line joining the point. What we can see that B1 strategy is basically joining the point from A1, 1 and A2, 3. So basically if I'm taking A1 as 1 and A2 as 3, so I can draw a line. The line may not be perfect for me because I'm writing in a pen tablet. So please, I'm trying to give you as much as I do. Yes. So almost. Almost, yes. So this line represent the strategy B1. Okay, to all of you? Is it okay to all of you? Similarly, B2 join 3, 0. From A1, it will take 3, and from A2, it will take 0. So, I am going to take a straight line joining the point 3, 0. And I can name this as the strategy B2. Clear to all of you? Similarly, B3 strategy joining the point 0 from A1 and A2, 1. So 0 and 1. 0 and 1. Please remember that if it is 0, A1, then I have to start with this and I have to end with here. Okay? Okay? And this can be B3. B4, what is that? 2 minus 1. 2 minus 1 means A1 is 2 and A2 is minus 1. Okay? A1 is 2 and A2 is minus 1. And this will represent the strategy B4. Why I am writing those strategy here, you will come to understand later. Is it okay to you up to this? If you have any doubt, you can ask me, please. Is it okay to all of you? Now, remember that what rule we have followed when you have find out the saddle point for the player A. Because this graph I have drawn for player A. Because these two vertical lines represent the strategies for the player A. So that obviously means when I'm trying to find out the solution, I have to look for whether it will follow the rule for the player A or not. And the rule for the player A was, what was that? Maximin. The rule for the player A was maximin. What is the meaning of that? Those who have attended the last class, they know very well. First of all, we are going to take the minimum. And then we are going to take the maximum. That is the meaning of the rule maximin. Clear? Okay to all of you? Now, what is the meaning of maximin in this context? The maximin mean is that, first of all, we are going to find out the lower envelope. How to get the lower envelope? Anyone? This is your lower envelope. I hope you agree with me. This is your minimum region. This is your lower envelope. Clear to all of you? Clear to all of you?
Yes, sir.
And then we are going to find out the maximum point in this lower envelope. So what is the maximum point in this lower envelope? Anyone? The maximum point in this lower envelope is this one. So this point, yes, so this point is your maximum point. Is it okay? So you can say the highest point in the lower envelope representing the maximum expected gain to player A. And it is basically the intersection of the strategy lines B3 and B4. I'm just writing for you. I'm just going to write down for the first problem because you have to write down this thing in the exam as well. You cannot write down only the matrix. Remember that. So I'm just writing for you. So the highest point in the lower envelope representing the maximin for the player A. Maximin for the player A. Okay? And this is basically is the intersection of what? Is basically the point of intersection equal, you can say, is the point of intersection of what? Of the strategy lines B3 and B4. Clear to you? Okay. So now what will be our reduce? Because as we are searching for the maximin point, and as the maximin point is coming because of the intersection of the strategy B3 and B4, so we can ignore these two strategy. Only it is required to have B3 and B4. So hence the reduce. So hence the reduce 2x2 game is what? What are the strategy will come? B3 and B4 for the player B, and for the player A, it will be remain as A1 and A2. So what are the entries for the player B? 0 and 2 and 1 and -1. Right? So 0 and 2, 1 and -1. Is it okay to all of you? Because this is the game graphical method, nothing else. After that, again, you have to use the mixed strategies formula to find out the optimal strategies for the player A and player B. Is it okay to you? Please. Is it okay?
Yes, sir.
So now we are going to assume the probabilities. So x1 and x2, this is the strategies for the player A, and y1 and y2, these two are the strategies. That means corresponding probabilities by which B is playing his strategy B3 and B4. Okay, so you can say y3 and y4 also to make it more clear to you, because as it is B3 and B4. So now recall what was x1, how to get the x1. What was that? Remember that x1 means first ignore that row, and then diagonal element, principal diagonal element is what? Bolo? -1, that is -2 divided by sum of the principal diagonal minus sum of the other diagonal, that is -3. What is that? That is half. X1 is half, so x2 will be automatically half, but you can cross check it also. If you want to find out x2, again ignore that row. Principal diagonal here is 0, it is 0 minus 2, and denominator will be always remain same for each and every x1, x2, y3, y4, as well as v also, value of the game also. That is going to be half. So now y3, now it's your turn. Tell me, what is y3? What is y3? Tell me y3.
On the numerator, it will be -1, -2.
-1, -2. Very good. And denominator is
-1
minus
and
4. Denominator is always remain
ha
same,
minus
-4. So basically it is 3/4. Very good. And what is y4? What is y4? You can do the calculation also. You can take 1 minus y3 also, right? If you take 1 minus y3, it is going to come as 1/4. But you can cross check it as well. That if you want to calculate y4, what is going to come? 0 minus 1. 0 minus 1 divided by -4, that is 1/4. Okay. And what is the value of the game? Okay, I'm just writing first. Thus, the optimal strategies for player A is half comma half, and for player B is, this is very important because here we are considering only y3 and y4, there is y1 and y2 0. So it is actually 0, 0, 3/4 and comma 1/4. And the value of the game is, what is that? Game V is what? I hope you remember that. Yes. Product 0 into -1, product of the principal diagonal, that is 0, minus product of the other diagonal, that is
2 into
2.
1.
That is -2 divided by -4, which is half. Okay to you? Is it okay?
Yes, sir.
Yes, sir.
just check one thing, देखो कितना interesting problem है ये, interesting theory है ये. Just take the strategy half and half. So basically what we are doing, we are saying that player A will play the strategy A with probability 1/2. Player A will strategy A2 with probability 1/2. Now if you multiply this, 0 into half, 1 into half, what is going to come? Half, the value of the game. 2 into half, what is that? 1. 1 minus half, that is minus half. This again you are going to get half. Check it for B as well. 3/4, 1/4. Check it. What is going to come? 3/4, it is 0. 1/4, that is half. Getting? Here it is 3/4 minus 1/4, that is 2/4, that is half. Is it okay to all of you? Is it okay to all of you?
Yes, sir.
So now I hope you have now understand that what is the purpose of writing this. A11x1, A21x2 is V. V is the value of the game. A12x1, A22x2 is equal to V. A11y1, A12y2 is equal to V. What is the purpose of writing those things? Now I hope you understand. Clear to all of you?
Yes, sir.
So now I'm going to give you the problem, which is last time we have done 2 cross n. Now I'm going to do m cross 2. Okay. Same way we are going to do it. First of all, what we are going to do? We are going to draw two vertical lines. And now these two vertical lines will represent what? Last time it was represent the strategies for the player A. This time these two vertical line will represent,
B.
yes, will represent the strategies for the player B. So now this vertical line represent B1, this vertical line represent B2. Now again we are going to do the same way. First we are going to find out the minimum of the number appeared in this payoff matrix, which is -3, as you can see. So here we are going to write down -3, and the highest point is 7. So we are going to start with -3, -2. We are going to write down each of the number, each of the integer value in between -3 to -7. Whether it is belongs to the payoff matrix or does not matter. So it is going to be -1, it is going to be -1, it is 0, it is also 0, 1, 1, 2. We are going to write down the number parallelly, right? 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. So the number -3 and -3 should be comes out. Up to this, I hope you have understand. Okay to all of you? Okay.
Yes, sir.
Okay. So now again, as we have done it earlier, what we are going to do, we are going to draw a line joining each of the strategies. So what you can see here, A1 joining the strategy B1 and B2 by 0 and -2. So a B1 is 0 and B2 is -2. B1 is 0 and B2 is -2, and you can write down this will represent the strategy A1. Okay. Next, A2 is the strategy joining the point 7 -1. So B1 is 7 and B2 is -1, right? So B1 is 7 and B2 is -1. Okay. This will represent A2. Okay. Am I audible to you?
Yes, sir.
Yes, sir.
So now what we are going to do next, we are going to join. Just give me 1 second. Now, is the screen is visible to you? Okay. So now A2. Similarly, A3 is what? Joining the point -1 and 4. -1 and 4. So -1 means what here, and 4 is here. Okay. -1 and 4, and this is A3. Clear? Next, A4 is -2, 6. -2, 6. So here it is -2 and here it is 6. You have to draw this very carefully because the lines are overlapping. And A5 is 5 -3. A5 is 5 -3. Although here it is not coming as a straight line because it's very difficult to draw for me to straight line in a pen tab. Okay, it is 5 -3. Okay, now just try to understand the logic. What we have done earlier, what we have searched for. First, we have searched for the last time lower
Lower
envelope
envelope.
because the logic was last time maximin. Why the logic was maximin? Because the graph what we have drawn earlier, that was for the player A. And this time what we are doing? This time we are drawing for the player B. So as we are drawing it for the player B, so what will be the rule we are going to follow? We are going to follow the rule for the mini max. Now, what is the meaning of mini max? Tell me. First, we are going to find out the upper envelope. There is a maximum, right? First, we are going to find out the upper envelope. And from the upper envelope, what we are going to do? We are going to find out
Minimum.
minimum. And what is that? This is the point. So this point is actually your minimax point. And here you can see that this minimax point is coming by the intersection of A3,
Sir, A2.
A4, sorry, A4, right? This is A4, right? Minus 2 and 6, and A2. So basically it is coming from the intersection of A2 and A4. Clear? Clear to all of you? Okay to all of you?
Yes, sir.
Yes, sir.
Okay. So hence reduce 2 cross 2 game is given by although I have written here, yes. Hence, just I'm writing it again because I've already write down this. Hence, the reduce 2 cross 2 game is given by. So you can see for the player A, the strategy remain is A2 and A4, and for the player B, the strategies remain as B1 and B2. And what are the point? Could you tell me what are the values? What are the
7
values?
minus 1 and
Yes.
minus 2, 6.
Very good. Minus 2, 6. Now, similarly, we are going to assume the strategies. So let us consider x2 and x4 is the strategies for the player A associate with corresponding probabilities by which A play his strategies A2 and by which A play his strategy A4. Similarly, y1 and y2 is the corresponding probability by which B play his strategy B1 and B2. Okay. So now tell me what is x2? What is the x2 value? Now I hope you have to remember this.
Eight by 11.
8 by 11. How it is coming 11? 7 plus 6, that is 13. Minus 2 minus 1 minus 3, that is 16. Denominator is 16, right?
Okay, sir.
And for x2, what is going to come? 6 plus 2, that is 8. 8 by 16, that is half. x4, x2 plus x4 must be equal to 1. So if it is half, that will be also half, but you can check it also. You can see 7 plus 1, that is 8 by 16 again. Again, it is half. Okay? Now y1. Now tell me y1. y1. Denominator is remain as 16. Numerator. Bolo. 6 plus 1, that is 7. And y2, y2 7 plus 2, that is 9. 9 by 16, right? And the value of the game, now you have to tell me. Value of the game, v. Numerator,
42.
numerator 7 into 6, 42. 42 minus 2, that is 40, divided by 16. So 5, right. So here the optimal strategy for the player A, the optimal strategy for player A is what? 0, half, 0, half. How many strategies are there for the player A? How many strategies are there? 5. So again another 0 will come. Okay, and for the player B, it is 7 by 16 and 9 by 16. And the value of the game is 5 by 2. Okay to you?
Yes, sir.
This kind of problem is going to ask in the exam, and you have to solve that. And if you do not understand here, I think it will be difficult for you to understand later as well, because from the book it is very difficult to get the solution procedure. Okay, now it may happen also that in the graphical method, last time what we have seen, only two line intersect at that maximum point or minimax point. But if more than 2 points intersect, then what is going to happen? So suppose that if I am considering a game where 3 points intersect at the maximum or minimax point, then how to get the solution? I'm just giving you the logic so that you can do it easily. So when we are going to do, first of all, as you can see that this is a game of 2 cross 4, right? So here the two vertical lines will represent the strategy for the player A. And now we are going to find out, see what? Minimum value and the maximum value in this pair of matrix, minus 1 and 6. So we are going to do that, minus 1, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Now what you are going to do, you are going to draw the line, right? First B1 is actually a line joining the point minus 1 and 6. So minus 1 is here and 6 is here. Minus 1 and 6 is coming here, right? Next is what? 3 and 2. B2 represent 3 and 2, joining the point 3 and 2. So here this one is B1 and here this is B2. Okay. Next is 2, 5, B3, 2, 5. So B3 is 2, 5. 2, 2, 5. Right. This is B3. And last is 2, 3, B4. B4 is 2, 3. So here also you are going to get 2, 3. So same. B4. Now as this is a game of 2 cross 4, so that's why first of all we are going to find out the lower envelope, because the rule is maximin. Remember that. The rule is maximin. So first of all you are going to find out the lower envelope. And from this lower envelope, what we are going to do? We are going to find out the maximum point. and here the maximum point is this. So this is your maximum point. Now you can see that this maximum point is coming from the intersection of B2, B1 and B4. Right? Right? Is it okay?
Yes, sir.
Now what we are going to do now? To solve this problem, what we are going to do, we are going to take the combination of B1, B2, B1, B4 and B2, B4. We are going to find out the solution of the each 2 cross 2 game. By considering B2, B1, you are going to get one pair of matrix. So if you consider B2, B1, B1, B2, you are going to get one game, right? And if you consider B1, B2, what is going to come? Pair of matrix. Anyone? -1, 3, 6, 2, right? -1, 3, 6, 2. So what is the corresponding strategies for the player A? X1 is what? X1 is what, bolo? 2 minus 6, that is -4, divided by -1 minus 2, that is 1, and 6 and 3, 9. So 1 minus 9, that is -8. It is half. And x2 is again, ignore this row, consider that diagonal element is -1, -1 minus 3, that is -4. So -4 divided by -8, that is half. Y1 is what? Y1 is 2 minus 3, right? So it is -1 divided by -8, that is 1 by 8. And Y2 is automatically come as 7 by 8. And what is the value of the game? -1 minus 2, that is -2. 6 into 3, that is -18, divided by -8. That is 20 by 8. 20 by 8 means 5 by 4. Sorry, 5 by 2. Okay to you? Okay to you?
Yes, sir.
So next, we'll proceed to take another two pair. B2 and B4 you can take. So you can take B2 and B4. So for B2 and B4, what are the B2 and B4? 3, 2, 2, 3, right? 3, 2 and 2, 3. So now tell me quickly, what is X1? What is X2? What is Y1? What is Y2? Tell me. And tell me also the value of the game. What is coming?
X1 is half.
Okay, good. X2 is definitely then half. Okay, sorry, you make it as 2, Y2 and Y4. So Y2 and Y4. What is Y2? y2,
Y2 is also half.
good. Y4 will be also half. V,
5/2.
5/2. Now you can see that both the game has same value, but the strategies are different. So this game has alternate solution. You are getting as you have done it alternative solution in that linear programming problem as well. You have seen that optimal value is remain same, but the optimal solution may different. That means x1 x2 values may differ, but the value is remain same. Same thing happen here as well. But the most interesting fact you are going to get when we are going to take the last pair, that is b1 and b4. Okay to all of you, what I'm trying to say? Is it okay up to this?
Yes,
Okay.
sir.
Okay. So now we are going to take the last pair, b1 and b4. So could you tell me what are the elements b1, b4 will come? Anyone? b1, b4? b1, b4 is what? -1, 2, 6, 3. -1, 2, 6, 3. Okay. Now here, if you are going to find out x1 and x2, what is coming? Anyone? Tell me x1,
Half.
half. x2 is also half then. y1. y1.
-1/6.
Yes. Now the problem comes. What you know that as x1, x2, y1, y2, y4, they all represent the probability. So this is not possible. As this is not possible, or other way we can say that this is not a feasible solution. So as this is not a feasible solution, so the combination b1 and b4 will not provide us the optimal solution. So it may happen that one of the pair does not give us the optimal solution. This is happening here. You can see that b1, b2 is giving us the optimal solution. B2, b4 giving us the optimal solution. Both solutions are same, but one of the pair is not giving us the solution, optimal solution. It may also happen. Clear to all of you?
Yes, sir.
Okay. So now the next method. Today we are not going to discuss that. I hope you have another class, right? So the next method, what we are going to discuss is the rules of dominance or dominance principle. I just want you to note it down and just go through it before coming into the next class. That's I want. That's why I've just typed all these things so that it will be easy for you to understand. And I just want that please keep this with you in the next class, and please read it this out. I do not expect that you are going to understand each and everything, but please read this out before coming into the next class. If you have any question, any doubt, you can ask me. I'm not going to continue further today. We have discussed one method, which is basically the graphical method, and we have seen that these graphical methods will help us to convert a game into a 2x2 game when the saddle point does not exist. So obviously, when any game is given to you, and if the question is asked to find out the graphical method or the dominance principle, then it is always good to first check that whether there is any saddle point or not in this game. It is always better to check this thing, and then you can apply the rule, because the rule is only applicable if the game does not have any saddle point.